All right, so for these problems, we are going from situation or word problem to equation or inequality. So in this case, our first one, I kind of streamlined the original word problem, and I pulled out the most significant words that apply to what we need to for the translation. So in this one, someone borrowed $150. They're going to pay back $15 per week. So that $150 is going to get chipped away every week until it goes away. We're asked to find an equation L owed in terms of T weeks. So how much money do they owe in terms of weeks? And then a lot of times for these problems we can consider looking at an example or a sample point and seeing if it makes sense when we have our equation. So let's go ahead and give it a shot. Our foundation here would be y equals mx plus b, because we have what's called steady growth here, or a steady decline. This $15 per week happens every week. It doesn't change at all. It's that 15 every week. So that would be our growth in this case, growth. Growth, when it comes into the equation of a line, matches our slope. The other one is the initial amount. The initial amount is $150 there. So that's the initial. Or the starting amount. How much did we start with in what context? Or sometimes they call it the initial. All right, so I'm going to just change out these variables and with the variables they want and the numbers they want us to use. So our variable for y is the total. In this case, it's the total owed. So L is equal to. Our growth in this case is they're paying back $15 per week. Now we got to be careful. This is the equation L owed. How much money do we owe? Okay, or does this, do we owe that person? All right, so we owe that person initially $150, and then it's getting chipped away by $15 per week. So that chip away idea is it's taking away $15 from that original amount. That take away $15 from that original amount. That means it's negative. So we're taking away that much every week. Our variable for x in terms of weeks, they're using the letter T. And our initial or starting amount, not too bad there, real clear. It's a positive $150 because that's how much we owed them initially. So you can kind of use, like I said, a test example to make sure you got it right. After 1 week, I borrowed $150. After 1 week, I pay them $15 back. That leaves $135. So if I put 1 in for here, 1 times negative 15, negative 15 is negative 15, and negative 15 from 150 is 135. So that confirms I've set up the correct equation representing the situation. Next one, we are buying drinks and candies. I buy at most 15 drinks and candies together. That together is a key word. That together, really important in math. It means you're adding something up. Write an inequality. All right, we're asked to use an inequality to represent this situation. Now that I kind of look at it, I think, okay, we're being asked to write an inequality to represent this situation. All right, so that's what we're being asked to do. A lot of times the directions for a word problem are at the end of the word problem. They're kind of tricky about it. Find an equation. So notice it's at the end. Usually when we ask somebody to do something, we tell them what we want them to do first, and then we kind of outline how to do it. Word problems, I don't know why they do it. They make it extra difficult for you. You have to weed your way through the text to get to what you need. So what I used to tell my students overseas, my English language learners, is I would say, if you can, try to start with the last sentence and kind of work your way back, and it kind of makes more sense what they're asking you to do and how to do it. So if we do that, we're asked to write an inequality to represent the situation. We are buying drinks and candies at most of 15. Okay, drinks and candies. Together. Oh, I like that together word. That makes it a little bit easier. Okay, so I'll call drinks. So drinks is number of drinks is equal to D. We always have to quantify it. The number of candies, I'll call that C. And together, it's at most 15. So I like to kind of represent it with what's going on first as the focus. So we're adding these together first. So the drinks together mathematically means D plus C. I'm adding them together. D plus C is at most. So this is at most. The drinks and candies at most. That's a key word. That's a math word, at most. So I always kind of compare it with like money. Sometimes we don't know what that means mathematically. If I have at most $20 in my pocket, does that mean I have more than $20 or less than $20? Okay. So if I have at most $20, it has to be less than that. And the next question is, can it equal $20? If I have at most $20 in my pocket or my wallet, does that mean I could have $20? Yes, it does. So the at most idea means it has to be less than or equal to whatever that number is, 15. Check. We're asked to take this word problem and create a system to represent it. So we're going from the situation to equation or inequality. Let's go ahead and take a look at what we got here. We have limited gold to make bracelets and necklaces. Bracelets take 8 grams, necklaces take 24 grams. We made a total of 13 bracelets and necklaces using 168 grams. Write a system to represent this situation. All right, so we are limited on this resource. So I like to think about it as what resource do we have or what quota do we have to meet? If it's a quota, we have to get at least that much. If it's a resource, then we have as much or at most that much. So this is a limited resource, limited by gold. So it's going to be something that has to be less than or equal to that. We don't know yet. We'll kind of see how this develops. Gold to make bracelets and necklaces. Okay, so that's what we're talking about. And the bracelets take 8 grams, so that's the relationship of the bracelets. Necklaces take 24 grams, that's the relationship of the necklaces to the resource. Limited gold, so that's how many grams of gold it takes. And we made a total of 13, so that's a relationship, how they're related to that number. Then bracelets and necklaces, they used 168 grams. Okay, so we know that it's an equal sign because we used that much. Write a system to represent this situation. So like I've said in the past, I like kind of going in reverse. So the last sentence here says write a system to represent the situation. So we need to make a system that represents this. First, we define our variables. So we got 2 things going on. We got bracelets and necklaces. So we let bracelets, number of, we have to quantify it, how many. I'll just use the sign, number of bracelets is equal to, I'll just say B. I had an extra E there, sorry about that. And number of, what's the other thing we were quantifying? Necklaces, number of necklaces. Let that equal N. All right, now, so we've kind of defined our variables. Then we want to start going through and looking at the resources and how things are related. Bracelets take 8 grams, necklace takes 24 grams. Okay, that's how they use the resource. They made a total of 13. All right, so total of 13. Definitely we can kind of jump on that. The total means we're adding them together. So the total of 13, I'm adding them together. So one of the relationships is B plus N has to equal, we made a total of 13. And using the resource used 168 grams of the gold. So 168 is the resource, and this is how much each of them used of the resource. So if I had 2 bracelets, I used 16 grams. 2 times 8. 2 bracelets, with each bracelet being 8 grams, means I would have used 16 grams. So it's the bracelets, however many there are, times 8. If I had 3 bracelets, I would have used 24. 4 bracelets, 32. So bracelets, 8B. 8 times the bracelets. Usually we put our numbers in front. Coefficient. So the necklace uses 24 grams each. So the necklace it uses 24 grams. So 24 grams for the necklace. And the bracelets and necklaces using 168 grams. And means both of them together. And the bracelets and the necklaces used 168 grams. So it's real important to kind of break it down to defining your variables. You have to quantify what they are, and then trying to find out how they are related through the rest of the problem. And like I said before, focusing on a resource or a minimum quota is usually how a lot of these are kind of related. And then almost always they use some sort of straight relationship. So one of them's a little bit more difficult to find. The other one's a little bit more straightforward. Notice that this one was just one line here. Total, bam, is 13. And then the other one, they made it more tricky. They broke it up into how they're related to the gold or the resource, and then how much of the resource we had.